Welcome to our lesson on one-step equations. This is a review lesson on adding and subtracting and then multiplying and dividing one-step equations. One-step equations was something that you learned about in 6th grade. But just to review, when you're solving an equation, your ultimate goal is to get x, or whatever the variable is, alone. To do this, I kind of have a little set of questions listed, listed right there for you. And those questions are kind of going to guide what we're doing here. But basically, we need to identify the number that's bothering the variable, and then we need to determine what operation is happening so that we can reverse it. We're going to solve each question and then plug the number back in to check our work. So let's get started. In question number 1, we see question number 1 right here. What number is bothering x? Well, I see it says x minus 17. X is not alone right now, which is our goal. And he's not alone because it's got a minus 17 next to it. So what number is bothering x? The number 17. What operation is that? Well, I said x minus 17, so it's subtraction. And then how do we reverse subtraction? Well, you learned in the previous video that adding and subtracting are opposite operations. They cancel each other out. So we would have to add. So this tells me right here, I'm going to add the number 17. Now, when you watched the video about properties of equality, what you learned is that if you do it to one side, you have to do it to the other side as well. So what we're going to do is we're going to add 17 over here and make sure your notes look just like mine. And then we're going to add 17 over here. Now these problems are not difficult at all, but the most important part here is that your work looks just like my work because this is the required work for equations. So you've got a little plus 17 on the left-hand side and a plus 17 on the right-hand side. Now if we look carefully, we can kind of see that right here shows, right here shows minus 17 plus 17. If I take $17 away and then I put it back, plus, basically what happens is that has canceled out. So we can go ahead and slash, and I want you to do this as well, slash that out because the minus 17 plus 17 canceled. And then I'm left with x equals 32 plus 17, which is 49. So I find out my answer should be 49, but I want to make sure that's correct. So I'm going to plug it back in, which is called checking my work. So instead of x, I'm going to replace it with a 49. 49 minus 17 should equal 32. 49 minus 17 does happen to be 32. So because both sides are equal, I know I got it right. Okay, on to the second question. What number is bothering x? Well, in this case, this problem is a little bit weird because it's flipped around. We can see x is on the right-hand side, which we don't see all that commonly, but I do want you to get used to it because you'll see it quite a bit in this class. It says x plus 12, so I know 12 is bothering x. What operation is happening? I said plus, so it's add. And then what will reverse the plus 12? We would have to subtract from both sides, and the magic number I'm going to subtract is 12. So minus 12 over here, and then minus 12 over here. Again, just like in the other problem, if we look on the right-hand side, 12 minus 12 is 0, nothing. So we're going to cancel that out and cross it out. 20 minus 12 is 8. So it's going to say 8. Then we're going to bring our equal sign down, and then it's going to say x. Now, the reason that x is over here in this problem and over here in this problem is because the way the problems are set up. So whatever side x is on originally, when you bring down your answer, that's where x is still going to be actually. Let's go ahead and plug it in really quick to check. So 20 equals, instead of x, I'm going to put 8. And again, this is called checking my work. So 8 plus 12. I do know that 8 plus 12 is 20. So 20 equals 20. I know I got it right. All right, on to the next question. What number is bothering x here? I see the number 8 is on the same side. Now, why is 15 not bothering x? Because sometimes people want to say 15 because they see the 15. 15 is on the other side of the equation. It's not anywhere near x. So 15 is not bothering x, but 8 actually is. And what operation is happening to x? It's a subtraction problem. It says x minus 8, so that's a subtraction. How do we reverse the subtraction? We would add. Okay, So what we're going to do is add 8 over here, and then add 8 over here. And again, minus 8 plus 8, that's going to cancel out. If you think of it as like negative 8, positive 8, those were neutral pairs back in our last unit, so they cancel out. And then we're left with 15 plus 8, and so we know that the answer will be 23 equals X. So again, your paper should look exactly like mine. Now let's go ahead and plug it in. 15 should equal 23 minus 8. So let's check it out. 23 minus 8, which is 15, and yes, that works. Okay, let's move this up a little bit. Next problem says x plus 15 equals 12. So let's go through our set of questions first. What number is bothering x? I know it's the 15. What operation is happening currently? It's add. And how will we reverse the add? We're going to subtract. Okay, so now what I'm going to do is I'm going to take away 15 over here, and I'm going to take away 15 over here. Remember what I do to one side, I have to do to the other. 15 minus 15 is 0, nothing, so I'm left with just x equals. Now, this problem's a little bit tricky because it says 12 minus 15. Let me write that over here. 12 minus 15. A small number minus a bigger number, we would probably want to do a leave change opposite. 12 plus negative 15, and we know that the answer is negative 3. Now, of course, in this case, because the problem is getting a little more complicated, we want to make sure it's the right answer. So I'm going to check my work. Instead of an x, I'm going to plug in a negative 3 plus 15. And negative 3 plus 15, you owe your friend $3. You have 15 is 12, so I know that it works out. Okay. On to the next page. You're going to try these problems by yourself. You'll notice that the set of questions is not there, but you're going to kind of answer the questions or go through the questions in your head in order to solve these problems. The only thing you need to show is all of the work. Then you need to show the answer, and next you're going to show that you're checking your solution, but you're going to do that in a few minutes. We're going to move on to the next part of the video for now. Okay, one-step equation, multiply and divide review. So we're going to review how to multiply and divide when it's a one-step equation. So first of all, we're going to ask ourselves the same guiding questions. What number is bothering x? And in this case, it happens to be an a. So I guess what number is bothering a? Sorry about that. And it's the number 9. 9 is kind of like attached down there. What operation is that? Well, this symbol right here, this kind of like division symbol, or fraction symbol is actually divide. So right now we currently have divide. And how would I reverse this? I would multiply. So I'm going to multiply this side by 9. And I'm going to multiply this side by 9. 9 divided by 9 is 1. So when I multiply and divide by the same number, it's going to cancel out. So I'm left with a equals negative 4 times 9, which is negative 36. Now, of course, I want to check this. So I'm going to go ahead and plug it back in. So instead of a, I'm going to say negative 36 divided by 9 should equal negative 4. Let's check it out. Negative 36 divided by 9 is, in fact, negative 4. Negative 4 equals negative 4, and we can put our check mark. Okay, let's try that again. What number is bothering x in number 2? This is question number 2. The number 2.4, we can see that it's kind of like attached to x over there. What operation is that? It's not a fraction, it's division. What reverses division? Multiplication. So we are going to multiply both sides by 2.4. If I do it to one side, I have to do it to the other. 2.4 divided by 2.4 is 1. Anything divided by itself is 1. So I'm left with just an x equals, and I don't know 2.4 times 3 in my head, so I'm going to do that on the side. 2.4 times 3. 3 times 4 is 12. 3 times 2 is 6, plus 1 is 7, and then bring your decimal over 1. So 7.2 is my final answer there. And of course I want to check it. So 7.2 divided by 2.4 equals 3. And 7.2 divided by 2.4 is in fact 3. So we know we got the right answer. Okay, next problem. 8x equals 64. What number is bothering x? Obviously it's 8. What operation is this? Now, when there's a number and a variable pushed right up next to each other, that is multiplication. So what operation is currently happening? multiply. How can we reverse this? We would divide. And so I'm going to divide both sides. And when I show division, I don't use the little bar with the two dots. I have to use the fraction bar in algebra, and we're in our algebra unit right now. The reason is because when the problems get more complicated, this is the most efficient and simplest way to do it. So 8 divided by 8 is 1. So I'm left with just 1x, or x, equals 64 divided by 8, which is 8. So that's my answer, but I want to check it. So 8 times 8 should equal 64, and it does. 64, equals 64. So I know I have the right answer. Okay, and last problem is a little bit more complicated. We're getting harder as we go. What number is bothering x? It's obviously 4. What's happening? It's multiply because it's the number and the variable pushed right next to each other. How do we reverse this? We will divide. Okay, so I'm going to divide by 4, divide by 4. Now, this problem isn't as obvious. X equals, now 22 divided by 4 is not going to be a whole number. You can make it a decimal if you want, but sorry about that. I really don't recommend it because it's going to make the problems harder later on. So what I would like for you to do, and I'm going to show the work off to the side over here. 22 divided by 4, I want to leave it as an improper fraction, which I know is new information to us. Usually I say make it a mixed number. In algebra, we're going to leave it as a as an improper fraction. But I can't leave it as 22 over 4 because that's not reduced. So what I'm going to do is divide by 2 on the top and the bottom. So 22 divided by 2 is 11. 4 divided by 2 is 8. 2. Okay, so now I'm going to go back over here, and it's going to say x equals 11 over 2, and that's my final answer. Now, the reason I want to keep it improper is because things get really easy for me when I go to check my work. So 4 times, instead of times x, I'm going to say times 11 over 2 should equal 22. When I go to cross reduce 4 and 2, the 4 becomes a 2, the 2 becomes a 1, and I can see 2 times 11 is 22. So 22 equals 22, and I know it works. Okay, it's going to be something you try by yourself, but it's not something that I have all the questions listed out. So you're going to try it by yourself and just kind of go through the questions in your head. All right, thanks for watching our review on one-step equations.